It's actually, and the definition that you see on the screen, this is typically a Google definition if you search business analytics, but just to give you a very basic understanding, business analytics is basically, as you all know, that data is becoming of primary significance in industries and organizations globally. And there has been various innovations in place, IT related innovations, wherein we can now capture huge amount of data. And when I say data, it is customer data, it is marketing data, any sort of data, digital information that we have, structured or unstructured, can be captured now and analyze, and there are systems in place which can store that much amount of data. And what industries and organizations are now moving towards is to be able to leverage that data. So earlier, if we just take a step back and we go to the say the 1980s or the 90s, their data would be mostly in form of hard copy files. So that's why when we see movies and when we see any movie which is basically from that time period, offices means huge cupboards with huge files on them, right? So that was data then. But now things have drastically changed, and as expected, they would change. And now data is all soft copy, all system based, and now you would see servers in those cupboards rather than files. So data has come a long way. Organizations have come a long way in with respect to capturing customer data, and now this much data that the organizations are capturing these days, what to do with them? Obviously you store them for your own reporting purpose, but more importantly, it is more interesting to find out unique trends from the data, unique patterns from the data. So this data that is getting stored it's like a gold mine waiting to be explored by analysts who have that skill and the capability to bring out interesting trends from the data that is being stored. So, and when we say data again, in our mind, immediately an Excel file opens up, right? And you have rows and columns and that kind of data, which is very natural. That what we are used to looking at data in a way we are used to looking at it. But that kind of data is usually called structured data. In today's world, when you must have heard the word big data, a lot of unstructured data has come into place. So big data is nothing but a lot of data, volume of data, and the velocity with which it is multiplying. So the data world has become very interesting of late, with a lot of unstructured data coming into place. And again, when I say unstructured data, I mean data, your social media data, your text data, when you interact with customer, the information and the tone in which the customer is speaking, that can also be analyzed and captured. So it's not just traditional row and column data, but it's also this text data and these other underlying data that is available in all these social media platforms is also very rich in information of customer preference, of prospective fraudsters. So a lot of this data can also be mined and used by the organization to kind of bring out these kind of insights, like what is the likelihood that the customer would kind of go for a new kind of product that the organization is trying to launch in the market, what is the interest level in a particular brand, risk from a risk side. Banks are working heavily with data and analytics to kind of come up with strategies which would help them identify customers whose likelihood to default in a loan is high than compared to customers whose likelihood is low, and accordingly they have been given loans and the interest rates are fixed. So coming to the utilization of this kind of data, so what we have established by now is that the world has changed. Of course, we all know that the world has changed the way they have been capturing data. Now a lot more data is getting captured, and hence organizations and industries are on their toes to kind of utilize this, leverage this information that they have into their decision making, into their business strategy design. So hence, what has become important is a career where we are hearing this term a lot, which is data science, data scientists. Earlier, we used to call them business analysts, business and or data analysts. Now, it is the it's just a terminology change, but what they usually do almost remains the same. Now we call them data scientists. They have become, because of course the people who are running the business, the people who are running the organization, will not have the skill to be able to, or more, in all probability, they may not have the skill. I wouldn't say will not, but they may not have the skill to leverage this huge amount of information that they are able to store now. So they need somebody to kind of work on that and bring in that set of skills to kind of work on that data and give them those insights. Hence, the career, which is the data science career, has become extremely important, especially in today's world. First is descriptive analytics. Descriptive analytics is all your visualization. So when you hear the term business intelligence in the market, it is basically referring to the work that you do with, which is basically pertaining to descriptive analytics domain of business analytics. And what is descriptive? It is basically gaining insights from the historical data. So it is basically telling the organization what has happened till now. So when we say descriptive, again, the word descriptive means you're describing the past and you're describing the present. And it is no less job. It is not just calculating averages and means and medians. It's not calculating basic stats. It is important to realize that it's extremely important for you to have a flair for visualizing your data, to kind of able to work with the data in such a way that it brings out the story to the organization. So, and when we say story, it's basically what has happened in the past, and you bring it up. Which are your, say for example, which are your most profitable customer segments? So you should be having that skill to understand from the data. Okay, what is the segmentation analysis? How do I undertake that? How do I then present it to my organization, to the senior management in the organization? Because that is extremely important, especially when you are involved in descriptive analytics kind of work, because there you have to, basically you will be involved in creating dashboards, you will be involved in creating reports, which would be easily and objectively able to throw out that message to the senior management that this is your risky area, this is your underperforming area, this is where you should go ahead and put in more resources. So segmenting your data into whatever required, whatever your business problem is, and what you are required to look at, and then basically going ahead and presenting it in such a way that it is easily consumed by the senior management to whom you are actually taking that report to. So this requires skills like, as I told you, data management skills, because earlier it was easier. So when I started my career in the early 2000, that time we didn't have the unstructured data part. We only had structured data. It was very easy, I would say, for me to in fact get accustomed to looking at that kind of data. And there are tools available where we can use. Basic Excel can give you a lot of insights into a structured data kind of a thing. But now when the advent of unstructured data is also in the market, wherein you have to learn text analytics to understand and the sentiment of the customer. So there's a huge topic called sentiment analysis also, which is in the market these days. And this is all making the descriptive analytics part very exciting, because before you go for any kind of prediction and forecasting and pricing and all, you want to know what are the trends in your data. You want to know your customers, you want to know your risky segments. So how do you kind of bring that out from the data is important, and for the organizations to that then go ahead and do some predictions or forecasting and bring out a strategy out of it. So descriptive analytics is a starting point for any kind of business analytics that you would want to finally go ahead and do. The skill, again, the skill levels for this is knowing platforms like Power BI, like Tableau. Sorry, just yeah. So knowing platforms like Power BI, Tableau, these are all data visualization platforms. These platforms essentially helps you to be able to work around with your data, and mainly it's all about graphs here. So you kind of how unique in a unique way how you can present your patterns that you've identified in the data. You can either give it in a row column way, or you can give it in a pie chart, or you can give it in a maybe a more a combination chart. So it kind of gives you it gives these Power BI tools and Tableaus, these gives you that ammunition to basically able to make your data attractive, make your insights attractive, and at the same time clearly giving out the message that you want to give out to the senior management. So descriptive analytics is in true sense what the business intelligence implies, and these Power BIs and all are the tools that are used to kind of work in this domain. Quickly coming to the other two domain, there is prescriptive analytics and there is predictive analytics. Again, if you become a data scientist, you don't have to get there are two ways to go about it. One is you know all of these type of work. So what you are able to do descriptive analytics, you are able to predict, you are able to also do prescriptive analytics, or you establish yourself to be an SME in any one of these domains. Both have their demerits and demerits, but what we are typically seeing these days is bigger, larger organizations usually go for people who have a focused experience into a one kind of problem solving, and that basically helps them to create center of excellences in their organization, within their organization. Whereas if you go to a smaller organization, say for example, because my background is BFSI, so if you go for an NBFC or a microfinance institute, they would be expecting you to have knowledge on all these three categories. Whereas if you go for a Citibank, if you are an excellent data coder, or if you're an excellent programmer, or you can, if you're an excellent BI person who can do your descriptive analytics very well, then you are valued accordingly. So we have seen in the market that the way they seek the skills in a data analyst is it's little different when with the size of the organization and the complexity of work that they do. So predictive analytics, as the name suggests, it is predictions, and this is where mostly your AI and your machine learning techniques are gaining a lot of prominence. This is essentially where I'm not sure about the level of statistics that you guys would be aware of, but all your regression analysis comes into this category, the predictive analytics category. It's nothing but forecasting. So learning from your past and then forecasting in the future. That is what the expert in predictive analytics does. So you see that we have connected the three categories because they're all interconnected. So somebody who is excellent in descriptive analytics will pass on the information to you as to say, this is the data, these are the segments, this is how you look at the data. And then if you are a predictive analytics expert, you will learn from that experience, that observations, and then you're going to use it in your prediction for the future. So that is how a team works in an analytics project. There would be people who would be excellent in looking at these trends and patterns and graphs, and then they pass on the information to somebody who is excellent in predictions, in implementing the regression analysis and implementing more statistically heavy algorithms. And then there is another group of analysts who are more focused into prescriptive analytics, and prescriptive is basically nothing but your optimization problems that you try to solve. So given these constraints, say cost constraints and supply constraints, what is the maximum that you can achieve? So that kind of analytics, when you do a lot of optimization, that kind of analytics is called prescriptive analytics. Now prescriptive analytics is organizations do use this kind of analytics, but mostly it is applicable to the supply side, the supply chain side of the economy, where there's a broader group which is termed as supply chain analytics, where you do a lot of optimization, problem solving. But the main core of a business analytics process is descriptive and predictive, even today. From a more objective perspective, you need to, I always say to our students also in IRISPO that it's a pyramid, and it's basically a triangle wherein you have to join all the dots to kind of become a confident uh, data scientist. First is you should have knowledge of statistics, basic statistics or advanced statistics, if you already, if that is the course that you have. Or if you don't have a course on statistics, if you don't have a knowledge on statistics, it really pays well if you can do a basic course of understanding the statistical concepts. Now again, you don't have to sit and derive equations, or you don't have to sit and derive any huge statistical uh, you know uh, differential calculus and all that you don't need to do. But basic statistics, like what does a regression do, what is a normal distribution, those kinds of terms that are there, basic stats course, basic stats understanding is needed for you. It's a prerequisite for a data scientist. Now why it is a prerequisite? Because of what do you do with the data otherwise? It's just not you. I agree there are platforms in the market where you don't have to know much of what is going in the back end. You just input the data and it gives out results. But that will not take you too far unless and until you are able to interpret the results that platform is throwing out. You won't reach much uh, you basically won't be able to cater to the objective that you have started your analysis with. So understanding stats, basic concepts of statistics is required for a data scientist to be able to make a mark for himself. Second part is basic knowledge of coding. Now again, data, that is taking me back to the data management point, wherein I was saying that you should be able to manage data. Now when I say manage data, is just not Excel, because the world has moved beyond Excel. There are platforms like Python, SAS, R, where the huge capability of managing data very fast and in a very optimist it optimizes the data processing into a large extent as compared to what basic Excel does. So when people ask me, okay, I know Excel, can I start being looking for a data science job? I would say a big no to that, because of course organizations do impart training. If you go to an entry level data scientist, you will get training, you will get trained on the current platforms that are being used in the organization. But it always helps for you to have some knowledge of any one of the tools that are being mentioned here. So that is the second part in the pyramid that I was talking about. So this is the, so if we are visualizing a pyramid, right side of it is your statistical knowledge, left side of it is your programming knowledge, your these statistical platform knowledge. And then when you bring it up to the, these are the two solid bases that you need. And when you bring it up, on top of it, you need to understand the industry for which you intend to work. And I think that is very important, which at least when we started off, or that is something that people usually don't kind of value much. And I'll just come to that. Before that, I'll just talk about the platforms again. So when you know the statistical knowledge that you have gained, as I told you, you are not expected to sit and write a regression equation. You're not expected to derive anything. You should be just able to know what one algorithm is doing, and what the tools that are there, these platforms that are there, are going to help you implement that knowledge. So like for example, as I was telling you, a lot of data is available down, structured, unstructured. There has to be a tool to kind of able that, so to kind of aggregate that data together in a comprehensible format, so that you can use your statistical knowledge to kind of on that data and bring out the insights, right? So though knowledge of those tools is very important. So hence SAS, I don't know if you guys are aware of, it has been the market leader for the longest time in statistical analysis and in analytics as a whole. But now, and R has been very competitive with SAS. R is preferred, largely preferred, because it's an open source. It doesn't come at much at a much cost, as a at a very high cost as compared to SAS. But now the, and what is being not mentioned here, and what I would like to mention, is Python, which is really gaining a lot of importance in the market, in the data science market. A lot of data scientists and programmers are moving towards Python because of the packages that are there, because the basically that I don't want to get too much technical into those terminologies, but basically Python provides a more flexibility with respect to analyzing your data as compared to SAS and R. And large organizations are moving towards Python as their basic analytics platform. So statistical knowledge, knowledge of analytics platform, SAS, R, or Python is important. Python is something which is now, what do I say, topping the charts. But R is also R and SAS is also something that is desired. So if you have knowledge in any three of these platforms, you are good to basically start your career in data science, along with your basic knowledge of stats.